Hello everyone, welcome back. I am finishing off the work here on the Hitachi HA270. I'm almost done. If you haven't seen the last videos, I did a full restoration. The amp came into the workshop basically working, but it still needed quite a bit of work. I changed all the capacitors, cleaned all the controls. I changed the RCA sockets in the back. They were really broken. They didn't give good contact anymore, and they were failing, all of them. And I rebuilt the power supply. There were some resistors in there that were burned and that really needed replacement. So those things were improved. Then the only thing that we still had to do was the bulbs here, because both incandescent bulbs of the VU meters, they were blown. But look, we have light. See? Wait, let me turn off the light here a bit. See? Nice. What did I do? I put some LEDs in there. Because the bulbs inside, they were really inside the VU meters and they are really hard to reach. It's possible, but then you need to take the VU meters out of the front plate, and everything, I think, is glued together. And also the VU meters, they are snapped. It's like one plastic enclosure. They are snapped together, so you need to pry them open. And then when you're inside, you still need to find the exact same bulbs. You can find them, but they are not common, and as a result, rather expensive. And they will blow again at some point. So I decided to change them with a couple of warm white LEDs. Let me show you how I mounted these inside. Okay, so as you see, I've got an LED here on the top of each VU meter. It's a nice 5mm LED, nice and big. And they are warm white, as I said. The original bulbs, you can see them in there. See, so it's those blue, shapes that you see in there, those blue cylinders. They are incandescent bulbs and they are wrapped with the blue plastic. So I think originally they would have been blue, but I like warm white better for these this vintage equipment. See if I turn it on. Yeah, it's working really well. Now I hooked them up with the dropping resistor, obviously, but then I first tried hooking them up on the 12 volt, which was originally intended for the incandescent bulbs. But yeah, that gave quite a bit of flicker on the LEDs. And I decided to just hook them up on the regulated 13 volts. So that's the red wire that you see over here. Let me just pan a bit to the left. See, that is hooked up over there. This is the plus 13 volts for the preamp and for the phono stage. That's a regulated, rectified and regulated 13 volts. So I decided to hook the LEDs into that rail and not into the 12 volts that was originally foreseen for the incandescent bulbs. Shouldn't matter a lot. They don't draw that much power anyway, and I'm not running them fully anyway. I put a 1K resistor in series with them, so they don't draw that much power. But yeah, and then I heat shrinked the leads of the LEDs. The resistor is inside the heat shrink here, and then I glued them with some hot glue here on top of this PCB, and they should stay in place rather well. And I'm actually quite happy with the result. If you are putting new LEDs in a VU meter like this, you have to really pay attention that you don't make them too bright. Resist the urge a bit to drive them too hard, because it will start annoying you after a while if you have an amp or a tuner or whatever running in your living room, and in the evening you have these hugely bright VU meters glaring in your face. So that's why don't exaggerate with the amount of brightness for the LEDs. I think the work on the amp is done. The only thing that is left, what we still need to do, is check a bit how it performs. So first we're gonna check how much power we get out of it, and then maybe play some music on it. But let me first do the setup here, so that we can check a bit the power of the amp. Okay, so I've got the amp running. If you hear some noise in the background, that's the rain on the roof. It just started raining again. So I've got the amp running. I've got both speaker outputs connected to a dummy load of 8 ohms. And I've got the amp off the restriction, so it's not going through the dim bulb limiter anymore. It's straight into the wall. And then I've got the signal generator connected to the aux input and the scope to both channels. See? So I'm gonna get you a bit of better close-up on the scope in a moment, but see, if I turn up the volume, you can see that we nicely get the signal on there. Yeah, so let me just give you a close-up of the scope. Okay, so I've got the left channel on channel 1, the right channel on channel 2, and if I turned up the volume, you cannot see a difference between them. See, they overlap nicely. They are quite identical. Let me just change the... Yeah, see, they are almost identical. And if you up the volume, you can see that they are a bit... Yeah, there is a slight change in amplitude. The right channel is slightly bigger in amplitude than the left channel. But hey, I think this is already pretty good for a entry-level amplifier. So as you see, I have a 1 kilohertz signal going in right now, and this is with the volume control more or less halfway. Okay, and this is the balance: left channel, right channel. Okay, my trigger is on the left channel, so cannot fully close it down, but that's working pretty well. Treble. Okay, oh, my treble was not at 0. No, let's put the treble at 0. But you can see that the treble is working. This is the bass. Yeah, on a 1 kilohertz tone it's also not gonna have a lot of effect. Loudness. The low pass filter, that obviously is not gonna have any effect on the bass. So I have bass, treble, balance all in the center, and the loudness off. Now, let's see how much power we get out of this thing. Obviously, I think I will need to change the scale here, the vertical scale here a bit. And let's run it and see where we hit clipping. You can see that there is a slight discrepancy between both channels. No, that's still not enough. But nothing major, and they are close enough. See, there we hit clipping. Okay, let's see how much volt this is. I'm not gonna leave it too long at full power, but let's try to see how much voltage it is that we get at clipping. There we are clipping, and that's 23 volts RMS. Now remember, this is a 25 watt rated amplifier. So if we do 23 squared into an 8 ohm load, that's 66 watts. So I'm quite happy with this actually. So it's a 25, I think in the specs it says 35 watts for a sine wave. But hey, 66, that's almost twice the rated power. If you take 25 watts as a reference, it's more than twice the rated power than what the amp is rated for. So that's quite impressive actually, on 1 kilohertz. See, and both channels clip equally, which is also nice. So yeah, really good performance here. So I'm really happy with this result, I think. Now obviously it's an entry-level amplifier, so it's not all, how do you say that in English? Happy days, let's say. There are obviously always some trade-offs with an entry-level amplifier. And one of the things is that the frequency response is not that linear. See, so this is now at 1 kilohertz. I have the volume halfway. Let me just change the scale here a bit so that we can see it better. Ah, this is perfect. Okay. So if I now, so I'm getting here in 5.6 volts RMS. I have 1 volt peak to peak, not 1 volt RMS. I have 1 volt peak to peak on my signal generator. And I get here 5.6 volt RMS for a 1 kilohertz tone. Let's say that we go to 20 kilohertz in the frequency. Still quite okay. See, it's 4.94 volts, which is still pretty acceptable, I think. Let's go to 20 hertz. And there you see that we are losing a bit of gain here. So here we are at 3.78 volts compared to 5.60, I think it was. So you see from 20 to 20 kilohertz, the response curve is not totally flat. You do get a bit of a drop-off on the ends, and more drop-off near the lower end. Oh wait, my low filter is enabled. Wow, okay. Forget everything I said. It's also 5.6 volts. You only get a slight drop-off on the high end, I think. Let me go to the high end again. See, 4.94 volt RMS. Yeah. 5 volts. But, yeah, still peak to peak, it's the same. Honestly, I am really impressed with the result that this amplifier is giving. Let me just try to go into clipping here on 20 kilohertz. No. There we are. Ah, one channel is clipping earlier than... No, it's just because one channel the amplitude is a bit bigger. Here we are clipping at 21 volts RMS. So, 21 squared divided by 8. That's still 55 watts. Let's go to 20 hertz. And then I need to lower this down quite a bit. Okay. Can we drive it into clipping at 20 hertz? Yes, we can. But it's also 23 volts. So it's along the same range of, let's say, 60 watts. Which is, yeah, more than twice what is specified on the box, let's say. I'm really, really impressed with this. Now, obviously, it has 2 channels. I mean, it has connections for 2 sets of speakers. And maybe that's the reason. They wanted to ensure that you would be able to drive 25 watts over 4 speakers. Maybe that's the reason. I don't know. But yeah, it's really good. I like it. Now, there is one small remark, and that's the following. It's not really a silent amp. Let's see if you go here. Now I have the volume control all the way down. I'm just going to disable my scope here. And if I hit auto on my scope, you'll see what I mean. See, we do have some noise on the, on the amp. And this is noise that comes from the power supply because, now it has a bit of difficulty triggering, but if I trigger here on the AC line, you'll see that it nicely triggers. So it's a it's a 50 hertz or a 100 hertz tone that is coming from the power supply, and it's exactly the same on both channels. See, so it's a bit of a hum that you have in there. It is about 100 millivolt peak to peak, 15 millivolt RMS. So it's not drastic. It doesn't really impact your music when you are playing music. Okay, well, forget about that remark. It was a clear issue of show me where you've been and I'll show you where the problem is. Because see, now the amp is dead silent. Look at that. Perfectly fine. And, well, the reason was the hum was really too annoying. So I decided to take everything out again and really search for where the problem was located. And when I got all the boards out, I fired up the amp, I tested, and the noise was gone. Then I put all parts back one by one. And then I noticed that I had an issue at the connectors here in the back that I replaced. I had some metal part of the ground of the shielding of the connector was touching the chassis. So I had a ground loop between chassis ground and audio ground, and that was causing the hum. And I fixed it by doing two things. First of all, I drilled the holes here a bit bigger for the connectors. Obviously I had to file it flat again. That took away the paint, so I'm still going to apply a new layer of paint on this cover plate that I made in the last video. But and then secondly, these connectors here, the bank of 3, they had some very small pins on the top, metal pins, that were connected to audio ground, and those were touching the chassis. Funnily enough, the bank of 2, they didn't have those pins. So I pinched these pins off, clipped them off, and as I said, I drilled the holes for my bracket bigger, and the noise is gone. So I am really happy now. I thought in the beginning it was the amp that was noisy, but then when I played some let's say music with silent passages or some piano music, some classical music, it was really unlistenable. You could hear the noise through the music, so that couldn't be right. Let me show you on the scope. What I'm gonna do is, I cannot put the scope and the amplifier in shot at the same time, but I'm gonna simply short here the ground of one of the connectors to this plate, and then you will see the noise coming back. Gonna do that now. See, there it is. So it was simply, a sort of ground loop or a short between the audio ground and the chassis ground. All right, now let me put the cover back on, and then I'm gonna hook up some speakers, and I'm gonna play some music, and I'll hope it comes across well on the video how nice this amp sounds, because it's really sounding great. Okay, so I've got some royalty-free music hooked up, and I'm gonna keep the microphone up to the speakers, and I hope that it comes across well on the YouTube video. Now, at certain point I'm gonna switch in the loudness switch, and I'm curious if you can hear a difference in the YouTube video, but here the difference is quite drastic, and I really like the sound of the loudness switch. Often on amplifiers I'm not a big fan, but here, the loudness switch is really improves the quality of the music, or improves the sound stage. I don't know how to explain it, but I really like the effect. So I'm gonna start with the loudness switch off. Okay, so here we go. Okay, I think that's it for this amplifier. I am really pleased with the result, actually, and I'm a bit jealous that it's not mine and I don't get to keep it, because I really started to love it while working on it. And as you hopefully heard on the video, it's really sounding great. The only thing I'm still gonna do is give that mounting plate that I made on the back for the connectors a new layer of black paint, and then we're done. Okay, so in the beginning I thought this was gonna be a one or maybe two videos, but in the end it turned out to be 3 videos. I'd like to thank you for watching and following along. I'm definitely gonna do similar things again in the future on my channel, so if you're interested, please subscribe, or liking the video also always helps. So thanks a lot for watching, and I'll see you in the next one. Take care. Bye bye.